Hi, this is Javin Kharod, a chemical engineer by profession, going to continue our today's topic, multiple effect distillation. Now, first question arises, what is that? Multiple effect distillation or multi-effect distillation is a distillation process often used for seawater desalination. It consists multiple stages or effect. In each stage, the feed water is heated by steam in tube, usually by spraying saline water onto them. Some of the water evaporate and then steam flow into tube of the next stage effect, heating and evaporating more water. Each stage essentially rescue the energy from a previous stage with the successive lower temperature and pressure after each one. There are different configurations such forward feed, backward feed, etc. And the plant can be seen sequence of the closed space separated by the tube wall with a heat source in one end and the heat sink in the other end. Each space consists two communicating subspace, exterior of the tube stage and the interior of the tube stage n+1. Each space has lower temperature and pressure than the previous space. The tube wall have intermediate temperature between the temperature of the fluid on each side. The pressure in a space cannot be equilibrium with the temperature of wall of both subspace. It has intermediate pressure, then the pressure is too low to temperature too high in the first subspace, the water evaporates in the second subspace. The pressure is too high or temperature too low, the vapor condenses. It carries evaporation energy from warmer first subspace to the colder second subspace. At the second subspace, the energy flow by conduction through tube wall, colder next space, nullly between the stages, the steam use some of the heat to preheat the incoming saline water. The thinner metal in the tube and thinner layer of liquid on either side tube wall, the more efficient is the energy transport from space to space, introducing more stage between heat source and sneak, reduce the temperature difference between the space and greatly reduce the heat transport per unit surface of the tube. The energy supplied is reused more time to evaporate more water, but the process takes more time. The amount of water distilled per stage is directly proportional to the amount of energy transferred. If transport is slowed down, one can increase the surface area per stage. Example, the number of length of tube, the expanse increase installation cost. The salt water collected at the bottom of each stage can be sprayed on the tube in the next stage since the water has suitable temperature and pressure near or slight above operating temperature and pressure. Next stage, some of the water will flash into steam as it releases into the next stage, lower pressure than the stage it comes from. The first and last stage need external heating and cooling respectively. The amount of heat removed from the last stage must nearly equal amount of heat supplied the first stage. For seawater desalination, even first and Barmah stage typically operate at temperature below 70 to 75 degrees centigrade to avoid scale formation. The lowest pressure stage need relatively more surface area to achieve the same energy transport across tube walls. The expanse installing the surface area limit the usefulness using very low pressure and temperature. In later stages, gases dissolved in feed water may contribute reducing pressure differential. This may allow accumulate in stages. External feed water must be supplied to first stage. The tube of the first stage are heated using external source of steam through any other sources of heat. Now condense. Fresh water from old tube in all stages must have pumped out from the respective pressure of the stage to the ambient pressure. The brine collected by bottom of the last stage must be pumped out since it has substantially lower pressure than the ambient pressure. Now, what is multi-effect distillations? Multi-effect distillations, known multi-effect distillation method used to desaline seawater. It is made up of several stages effect. The feed water is heated each stage by steam through tubes, which are frequently sprayed with saline water. Several of the water evaporate and steam goes into flowing stages tube, heating and evaporating more water. Each step effectively recycles the energy from the one before it with progressive lower temperature and pressure. There are various configurations available such as forward feed, backward feed, so on. In addition, the steam utilizes some of heat to warm the incoming saline water between phases. Now, operation of the multi-effect distillation. The plant can be thought of series closed chamber, divided tube bowl, each with heat source one end and the heat sink to the other. Every space is made up two communicating subspace. Outside of the stage tube and the interior stage N plus 1 tube. Each compartment lower temperature and pressure before it and tube bowl temperature. They are halfway between both the fluid temperature on each side. The temperature of whole subspace cannot be balanced with the pressure in space. It has pressure that's somewhere in the middle. Water evaporates because temperature is too low. Temperature is too high in the first subspace. Vapor condenses in second subspace because pressure is greater and temperature is too low. Evaporation energy is carried from warming first subspace to colder second subspace. Through this, the energy travels to the colder next subspace via conduction via the tube bowl of the second subspace. Now, multi-effect distillation process. Lower temperature multi-effect distillation is a straightforward, dependable and cost-effective method. The makeup use low-cost, low-grade heat and waste steam. Vacuum allow ultra-flow distillation temperature below 70 degrees centigrade, reducing scale and corrosion as well as maintenance bare minimum as result of huge number of effect. Very high economy ratio produced. The steam are achieved in this use aluminum tube to improve heat transfer result, cheaper investment cost, and then traditional high temperature process, direct transmission, latent heat is used to achieve evaporation and condensation, eliminating sensible heat pickup which would reduce effective temperature differential. The static head is removed, flashing process using falling film principle, resulting high evaporation, heat transfer coefficient, lower thermal driving force and lower energy requirement are provided by this variable. They are combined with generously constructed heat transmission surface. They are also significant pumping power saving because of brine calculation rate is other magnitude lower than the required for circulation system. Now, multi-effect distillation plant are commonly used power plant, refinery, other industries and other high availability, reliability and maintenance cost as far as advantage of their multi-effect distillation. They are capable of producing boiler feed water with less than 10 part per million TDS, means total diesel solid, superior in availability and dependability, adaptable with low load flowing capacity, extremely efficient with option using low cost waste heat energy source. Other advantage multi-effect distillation are lower energy consumption with compare other thermal process, avoid corrosion and scaling by operating lower temperature 70 degrees centigrade and lower concentration 1.5, does not require any pre-treatment of seawater and can withstand wide range of seawater conditions. Extremely dependable and simple to use. Continuous operation with minimal monitoring 24 hours day and 7 days a week. Can be used any type of heat source such as hot water, waste heat from the power plant, industrial process and solar heating. Consistently produce high purity distillate, lower energy consumption compared to other thermal process, and lower concentration, does not need pre-treatment of seawater and tolerate variation in seawater condition, high reliable, simple to operate, lower maintenance cost, and can be adopted any heat source including hot water, waste heat, power generation, industrial process, solar heating, produce steadily high purity distillate. Now its disadvantage: incompatible with higher temperature heat source due to scaling issue during spray evaporation, difficult to scale down to small size due to complexity and large number part required. Now, multi-stage flash distillation is a water desalination process that distills seawater by flashing portion of the water into steam. Multiple stages. Water essentially counter current heat exchange. Current facility may have as many as 30 stages. Multi-stage flash distillation plant produce about 26% all desalinated water in the world. Almost all new desalination plant currently use reverse osmosis due to much lower energy consumption. Principles: the plant has series space called stage. Each contain heat exchanger and condense collector. The sequence has cold and hot, and while intermediate stage have intermediate temperature. The stage have different pressure corresponding boiling point of water. Stage temperature after hot and their container called brine heater. The plant is operating in steady state. Feed water, cold inlet temperature flow, or is pumped through heat exchange in a stage and warm when reaches brine heater is already has nearly maximum temperature. In heater, amount additional heat is added after the heater. Water flow through valve back. The stage have ever lower pressure and temperature. It flow back through stage. Water is now called brine. Distinguish it from inlet water. Each stage as brine enter, temperature above boiling point, pressure of the stage and the small fraction of the brine water boil. The steam therefore reducing the temperature until equilibrium is reached. Resulting steam is a little hotter than the feed water heat exchanger. The steam cool condense again heat exchanger tube, therefore heating the feed water described earlier. The total evaporation in all stages is up to approximate 85% of the water flowing through system depending on range temperature. Within increasing temperature, there are growing difficulty, scale formation and corrosion up to 110 to 120 degrees centigrade appear. A maximum all through scale avoidance may require temperature below 70 degrees centigrade. Now, the feed water carries away latent heat of condensed steam, maintain lower temperature of the stage. Pressure in chamber remain constant, equal amount of steam form. When new warm brine enter the stage and steam is removed as it condenses on tube of the heat exchange. The equilibrium is stable because some of point more vapor form. The pressure increases that reduces evaporation and increased condensation. The final stage, the brine and condense, has temperature near the inlet temperature. Then the brine and condense are pumped out lower pressure in the stage of ambient pressure. The brine and condense still carry a small amount heat that is lost from the system when they are discharged. Heat that was added heater make up the loss of heat added brine heater usually come in form of hot steam from industrial process co-located by the desalination plant. The steam is allowed to condense again tube carrying brine. The energy that make possible evaporation is all present brine as it leaves the heater. The reason for letting evaporation happen in multiple stages rather than the single stage, lowest pressure and temperature is the single stage. The feed water only warm intermediate temperature between the temperature and heater. The much of steam would condense. The stage would be not maintain lowest pressure and temperature. Such plant operate approximate 90 millijoule per meter cube distilled water because of colder salt water entering the process. Counterflow The saline waste water, distilled water, relatively little heat energy leave outflow. Most of heat is picked up by colder saline water flowing toward the heater and energy recycle. Addition, distillation plant, especially large ones, they are often paired with the power plant. Concentration and configuration. Waste heat from the power plant is used to heat the seawater, providing cooling for the power plant at the same time. They reduce the energy need half, two-thirds, which drastically alter the economic of the plant since energy is far largest operating cost of the plant. Reverse osmosis, distillation, when competent, require more pre-treatment, seawater, more maintenance, as well as energy in the form of electricity, mechanical power, as opposed cheaper, lower grade waste heat. Okay, guys, this is up to our today's topic, multi-effect distillation. I hope you get sufficient knowledge after watching this video. Next Sunday, we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.